Controversy abounds within the field of land change modeling concerning the number of time points to use when calibrating extrapolation models. This video explains the difference between using one time point versus 2 time points for calibration. This research is based on Jessica McDermott's master's thesis, supervised by Professor Pontius. This video is brought to you by Sara and Carly Robbins. We illustrate the principles with a case study using the Plum Island Ecosystem long-term ecological research site located in northeastern Massachusetts. We use the land change model GeoMod to show the concepts. GeoMod is a module in the TierSet software available from Clark Labs. For more information on GeoMod, please see the other videos in the series. A one-time point calibration requires a dependent variable at one time point, in this case built versus non-built at 2011, as pictured on the left. Built at 2011 is black, and non-built at 2011 is gray. We use one independent variable, in this case superficial geology, to explain the transition from non-built to built. Geology is appropriate because we suspect builders consider geology when deciding where to build, and geology is consistent over long temporal extents. The map on the right shows 4 geology types. GeoMod calibrates a suitability value for each geology type. The suitability of a certain geology type for transition to built is equal to the size of the built on a geology type divided by the size of that geology type. A 2 time point calibration requires a dependent variable of the change between 2 time points, in this case the gain of built versus persistence of non-built from 2001 to 2011. The map on the left displays the gain of built in red and the persistence of non-built in gray. Built at 2001 is in black and is eliminated from the analysis, because built pixels at 2001 are not pixels that can experience gain of built during 2001 to 2011. Again, GeoMod calibrates a suitability value for each geology type. For the 2 time point calibration method, the suitability of a certain geology type for transition to built is equal to the size of the gain of built on a geology type divided by the size of that geology type that is not built at 2001. This equation differs from the 1 time point calibration because the 2 time point method excludes the region that was already built at 2001. Figure A shows the suitability values from the 1 time point calibration approach. Figure A displays the percentage of each geology type that is covered with built at 2011. The black dotted line indicates that 42% of the spatial extent is built at 2011. Figure B shows the gain of built from 2001 to 2011 as a percentage of each geology type that was non-built at 2001 and that experienced a gain of built from 2001 to 2011. The black dotted line indicates that 5% of non-built at 2001 transitioned to built from 2001 to 2011. The longest bar in each graph shows the category that is most suitable for future change according to each calibration method. The 1 time point approach on the left shows that gravel has the highest built percentage. The 2 time point approach on the right shows that bedrock has the highest gain of built percentage. GeoMod uses these percentages to create suitability maps, which the next slide shows. Map A shows the 1 time point calibration suitability map, where gravel has the highest suitability for future gain of built. Map B shows the 2 time point calibration suitability map, where bedrock has the highest suitability for future gain of built. Linear extrapolation of the gain of built from 2001 to 2011 implies that pi would transition from 42% built at 2011 to 66% built over a duration of 75 years. GeoMod allocates this quantity of the gain of extrapolated built at the non-built pixels that have the largest suitability values. We performed 2 GeoMod runs, one run using the 1 time point suitability map and a second run using the 2 time point suitability map. This map is an overlay of the 2 output maps from the 2 GeoMod runs. Black is built at 2011, gray is non-built persistence used in both calibration methods. Yellow is gain of built using the 2 time point calibration method. Red is gain of built using the 1 time point calibration method. There is no intersection between the extrapolated gain of built from the 1 time point method and from the 2 time point method. This demonstrates how the method of calibration can have a dramatic influence on the extrapolation. The one-time point calibration method is based on the state of the landscape at a single time point, which reflects the accumulation of long-term trends. The allocation of built at a one-time point reflects decisions concerning where humans have built from a time prior to human settlement. In our study area, humans have historically concentrated built on gravel. The two-time point calibration method is based on the change of the landscape between two time points, which reflects shorter-term trends. In our study area, humans have concentrated recent gains of built on bedrock. The number of time points can make a difference in calibration and extrapolation. One time point can give a stronger calibration because the implied temporal extent is from the natural non-built state to the one time point. Two time points can give a weaker signal for calibration because the two time point method focuses exclusively on change between two recent time points. The appropriate number of time points depends on the purpose of the model and the stationarity of the change processes. If the recent change processes are stationary with the historical processes, then we recommend you use the one-time point calibration method, because the one-time point calibration tends to use a stronger empirical signal. If the recent growth processes are expected to continue and are non-stationary with the historical processes, then we recommend the two-time point calibration. When in doubt, use both methods to show how much difference it makes. The National Science Foundation supported this work via the Long-Term Ecological Research Network's Plum Island Ecosystem site. The Massachusetts Office of Geographic Information and the National Land Cover Database supplied the data. Here is our contact information. For more information on GeoMod and TierSet, please visit clarklabs.org. Please see more videos at the website of Professor Pontius, and may all your modeling experiences be insightful.